In this lesson, we're going to learn how to attach behavior to graphical user interface components. To invoke programmer-specified behavior when a user interacts with a component in a Java GUI, we use an approach known as a callback. To make this happen, we write our code in a class that implements a predefined interface and then give the component an instance of the class with the instructions, when such and such happens, please call the something or other method in this object. In this example, such and such can be any of the user interactions, such as typing a character in a text field or clicking on a button, and the something or other methods have all been predefined for the particular user interactions. Let's get a little more specific. One very common user behavior is clicking on a button. We'll implement this in the project GUI2. So here's our project, and here is the main file for it. Notice that we come down here into the main method, which is where it starts, and this starts by creating an instance of the GUI2 class, which is this class. Then as soon as it's created that, it calls the go method on that instance. What the go method does is to interact with these three private member variables, a JFrame, a JButton, and a JText area. It creates the JFrame and gives it the name GUI components. It sets the layout on the frame to be a 2-row, 1-column grid. Then it creates a JButton with the label click me and a JText area which represents multiple lines of editable text, and it sets up initial text within there to say edit this. Then it adds the button to the frame and adds the text to the frame, sets our close operation so that we'll actually quit the program when we click on the close button, sets the bounds and makes it visible. So let's just run that, and we see that we get pretty much what we would expect. There's our button, there is our editable text field, we can type into this thing, and it has multiple lines. We can resize things and we can click on the button, though it doesn't do anything yet. Okay, so we'll close that up. Now to add behavior to this button, we must create a class that is the shape, for the want of a better word, that the button expects. This is a bit like saying that when you have a blocked drain, you call a plumber, and you have certain expectations about instructions you can give to the plumber. You'd be really surprised if you said, please Mr. Plumber, unblock this drain, and the person you'd hired said, I don't do that. Similarly, the button is going to have expectations about the code we give to it. Specifically, it expects to be able to say, in a formalized way, I just got clicked. We're going to do this for the sake of convenience in the same source file. Now normally this is not a great idea, but it allows us to put all the code in one place, which makes it easier to understand. Actually, the only way Java allows this is if we make the class not public. That's a bit odd in itself. So just remember this is a learning exercise and not something that you should do as a rule. We'll call the class myButtonHandler. So I'm going to scroll up here and we'll create this right here. And it needs to implement this interface action listener because that is what the button expects. So we will also need the import for the action listener. And then we'll notice that as soon as we've defined the action listener interface, the compiler is now saying that myButtonHandler doesn't actually implement the methods that we've said it will implement. So if we click on here and click the Implement All Abstract Methods, you'll see that NetBeans will fill in the blanks for us. It says that to be an action listener, you must have this method, action performed, returns void, takes an action event as its argument, because that is the method that button expects to call when it's been clicked. Now the way NetBeans has created this method, it's going to explode in our faces if we try to use it, because it has this exception in there saying we haven't written the code yet. So we'll replace that with something slightly more useful. So here we say, just print out a message, button was clicked. So let's just print out a message, button was clicked. Now the next thing we need to do is to arrange that the button can call this method when it gets clicked. We do this by creating an instance of this handler class and passing it to a method in the button called addActionListener. So we'll come down here, and just after we have created the button, we will say the button addActionListener new myButtonHandler. We create the instance of this class and pass it to the button and tell it to add this as a listener for actions. That means that when the button gets clicked, it will call this object dot action performed to tell it that the click has occurred. So let's save this and run it. If we click on the button, you see that we now get the message in this console down here, the button was clicked. That looks like a good first step. Of course, we might want to do something more imaginative than just printing a message on a console. Let's assume that we want to update the text in the text area. We would need to call a method called append in the text area to do that. But we don't have a reference to the text area in our handler. Now, we could modify the listener so that we pass it a reference to the text area when we construct it. In other words, add something here so that we have a way to store the reference to the text area in here, and then when we construct it, new MyButtonHandler and provide the text as an argument. But that's a bit cumbersome, and while it would work perfectly well, remember that a private variable in an object is accessible between the curly braces that enclose it. In other words, the text is visible from this opening curly brace right the way down to here. Now it turns out that we can actually create one class inside another class. We can even create one inside a method. So let's take this class, we'll cut it out of there, clean that up a little, and then we'll move that inside here. We'll reformat it. Notice no complaints. It looks a little odd for sure. We've got a class defined inside the Go method. Let's save it and run it. And sure enough, when we click it, button still prints the message it was clicked. So what we can do now, in this method, we can refer to this variable the text. And that means that we can say the text dot append button clicked at plus new date. So we'll put a date and timestamp on the end of there. Put a semicolon on. We'll also put a new line character that's represented by \n into that, and we need an import for java.util.date. So now if we save that and run it, let's make the window a little bigger, and each time we click it, we'll see that we get a message appended to the text that says button clicked at and the timestamp. Now there's actually another shortcut you'll often see experienced Java programmers use in this kind of situation. Notice that there's really only one use for this particular class, the MyButtonHandler class. Well, the chances are that we only ever create an instance of it right here and immediately attach it to the button. Java actually allows us to skip giving this class a name. So watch what happens here. I'm going to delete this constructor here and put some blank space so that the whole of this area is the space for the parameter to the addActionListener method. I'm going to change this class so that instead of saying class MyButtonHandler implements ActionListener, I'm going to say new ActionListener and put parentheses on the end of it. And then I'm going to cut this out of here and embed it in here. Now it wants a little reformatting. We clean it up, but now what we have is we have this new ActionListener parentheses, and there's the opening parentheses, there's the matching closing parentheses, and we're actually creating an instance of an unnamed class that implements ActionListener right here as the immediate argument to this method. Let's save that and run it, and you'll see still that when we click on it, it behaves just as it did before. So in effect, what I did was I moved the class definition into the method argument. I dropped its name completely and just said new ActionListener. It means the same thing, but this is called an anonymous inner class. You don't actually have to use this form if you don't want to, but you will have to be able to read it, as it's really popular with Java programmers because it's brief. As a final note, You might be wondering where all these methods, interfaces, and so forth are coming from. Well, after a while, you'll start to know some of them just because you use them a lot. But mostly they're in the documentation. Let's take a look. Here's the documentation, and in this top left corner, remember, we have all the packages. Well, it turns out that the Swing package happens to be in a javax.swing package. So as we scroll down here, there we find javax.swing. Here is the javax.swing package as a whole, all the classes, all the interfaces, and so forth. And this is the general top-level documentation for javax.swing. So, for example, in here we'll find lots of things like a JLabel, a JList, a JList drop location, a JMenu, a JMenu bar. Many of these look as though you could probably make a reasonable guess as to what they do. A JRadio button, a progress bar, and so forth. Well, if we look at the JButton, we get the documentation over here. If we scroll down to the constructors, you'll see that we can create a JButton and we can give it a string text argument, and it creates that button with the specified text. So that becomes the text of the button. Also in this JButton class, we will see that we can find the addActionListener method. This is actually inherited from a parent class AbstractButton. In other words, there are multiple kinds of buttons. Radio buttons and checkboxes are types of button, for example. And if we look at that, that one tells us that it adds the action listener to the button. We can click on the action listener argument type and discover that the action listener declares the action performed method and tells it that it will get an action event when it's invoked. Let's take a quick look at the action event. Here you see that inside an action event, we have a number of methods. We can get when to find out the time that this action occurred. We can get modifiers to find out if there were keys held down during the occurrence of this action, and so forth. Similarly, if we come across back to our main list of classes, we can find that we come across the JFrame. And the JFrame will tell us things that we can do with that. So we can construct one and give it a title string. We'll also see that we can have a setBounds method, which is actually inherited from a parent class, a window. There's a couple of those, but if we click on this one, we'll see there's a setBounds method that takes an x, y, and a width and a height. So these are the kinds of things that we would do to work out how to do something that we've not seen before. A little bit of imagination and a little bit of scrolling up and down this documentation will allow us usually to work out most of the things we want. So, this lesson looked at adding behavior to a user interface, and along the way we took a look at how we can define classes inside other classes, and in particular at this curiosity called the anonymous inner class.